have the time to do the live analysis, of course, it is also possible to do recording. So there you do just the settings like you know, set the distance, set the time. I set it to 32 seconds now. It is okay to measure with a lower sampling rate. Right, Andy? For intensity,
well, then,
48 kilohertz for intensity is okay, right?
Yeah, that's okay.
So I go to record. 3 triggers running. And the recording is starting now.
Very important is now that the 10 centimeters, the distance to the object is nearly constant, yes. That is very important. Yeah.
Okay, so I scanned a little bit more than I need to, and now it's transferring the data. So I covered a very big area, and the result is the channel file. Then different ways of working with it. Either I do it exactly the same way by right-click, spectrum, and then let's say to 500 again. Mark the frequency I'm interested in, right-click, near field. And why I think that this can be a little bit more complicated is that whenever you mark something, it will find a source. So if I go through the time now, it will always find something. But it's jumping around. The only steady thing is this in the left corner. But this is all not a clear source. This is just an indication. Then if I get an image like that, this shows, okay, this is my source. So what I can do now is now I see it's around 82 dB from to 79 or something. I could increase my threshold and I could say, okay, everything below 76 dB is not interesting for me because this is my loudest source. Then I know, okay, this is all not sources here. And then only when I'm really at the source, it finds it. This is one easy way to work with it. So here the same, even from another perspective, I reach it, work with the spectrogram. So we have a 32-second measurement, and I can look at the complete measurement, right-click, open the spectrogram, and go down to maybe 1000 Hertz. I have to change the resolution a little bit. Yeah, probably something like that. So right now I also see those low frequency parts which I'm interested in. And here I can basically instantly see where the loudest parts. So of course I have something around 50 Hertz. If I right click, make photo 2D, it will, photo 2D, sorry, mistake. Of course, near field. So if I don't have any threshold, it will show me something. But in the real measurement, you instantly see that this is noise because it's just jumping around. So if I move in that area of the low sound, there's something always, but jumping around. So normally what you do is you go and check for the loudest part. This is the loudest part. There we have that very, very clear noise. And take that as a reference. And then we can do the same by putting in a threshold. And then we can look at the data and see, okay, whenever we are over that threshold, we are at this position. So this has to be our loudest sound source. So the spectrogram already shows us very well where the loudest noise is coming from. In that case, absolutely, it's harmonics to that frequency range. Very clear harmonics, yeah. Okay, yeah, this would be the examples for the post-processing. And of course, if you have, as I said in the beginning, if you are not able to do the live, if you, let's say you don't have enough time or something, you can of course cover the complete car like that, but it works of course better if you do it live and have the time to really find the source.